Thank you for these interesting talks. Now we have some time for discussion and questions. So let's see. I can start with a question to Octavio. So it seems from your pictures that indeed is the accumulation of losses. They correlate well with the visual results. How would you analytically assess your results, for instance, to compare with other state-of-the-art methods?
I think it's probably difficult to answer whether or not analytical results would be able to provide the same answer. I mean, at the end of the day, also neural networks are some sort of not analytical method, but just an approximation of certain optimization procedure. So I think it would be the same question as answering how the theoretical neural networks would be able to provide the results. So I think it's a complicated answer.
Yeah, indeed. Thank you. Let's see, we have more questions. Well, I have a question for Gefersom. So have you tried comparing your approach to other methods of seismic phases segmentation?
Hi. I didn't compare my method with others methods that not use deep learning. Yet it will be my work in the PhD.
Great, let's wait for that. Thank you. And yeah, let's see more questions. I have a question for Nicolas. So in your model, how do you model the overload of subjects to the students? You somehow model it?
Thank you for your question, Eric. For overload, do you mean that a student enrolling in too many courses?
Exactly.
Yes. So in our data set that comes from the Universidad Metropolitana, the maximum courses that students can enroll in one term is up to 6 courses. So we define a maximum length of courses in a given term to 7. So we haven't tried specifically for overload of courses, but we have students that enroll in 2, 3, 4, or up to 6 courses. The model is responding very well in all these different cases.
Okay, thank you. Yeah, Nicolas, we have another question for you from the audience. And how did the model compare to, say, linear regression model or SVM? And second one, have you seen any possible routes to account for bias in your model? In short, he wants to, yeah, that's it.
Yes, so as a work in progress, we are working right now on the benchmark with existing models and methods. So we haven't tried or we can have an answer right now for a comparison with existing models. For the possible routes for bias, we developed the architecture in order to have the minimum possible bias terms. Let's say the professor of the course, the hour in the day that the course is given, the sex of the students. So we want to reduce the bias information just to grades and terms and courses. So what we are trying to understand right now is a possible bias for the cold start of the model in the terms of the beginning of a career of the major. So we are working on that.
Great, thank you. I think we have another for you. And so what are some of the main differences that you see when designing these types of intelligent educational systems for Latin America, say Venezuela, versus other regions, say in US? And congratulations.
Yes. So we haven't seen any difference geographically on this type of models, but what we have seen indeed is a difference between models that try to understand the educational data mining process of MOOCs like Coursera, Udemy, and they try to understand or they try to predict on a limited time frame. So they want to understand if you pass the first quiz, how it's going to be your next quiz or your final exam. The main difference on what we are doing is we are trying to predict on a much middle time frame. So we don't have information about the course that the student is going to attend. That's the difference that we have understand and that we have seen between our work and the work that it's on the research in the educational data mining.
Cool, thank you. So yeah, I have a question for Matías. So in your work, you mentioned you tried the standard ensemble techniques. Have you also considered boosting?
Okay, thanks. Actually, we are still researching a little more about the ensemble techniques. What we try is just to combine a different number of models using different sampling of the categories for train and test. And what we showed recently is just a short table. We try different numbers, but in general, the conclusions are the same.
Okay, thank you. I have another for you. What can we conclude from these high standard deviations from both methods you try in the two coarse grain data sets?
Okay, thanks. That's a nice question. Maybe the way that I found to answer your question is thinking in the fine-grained cases, why the variability is lower. And I think is because the categories are more similar. So the different domains, the train and test moments, stage, the difference are low. So the model have better adaptation, you know. In the case of coarse grain contrast, the categories are more different. And then the generalization of the model in training stage is more difficult to adapt to the testing stage. Am I answering your question?
Yeah, absolutely.
Thanks.
Thank you. Yeah, we have another question from the audience to Octavio. Have you considered inserting these visual inspections into the training loop?
Hello, thank you. Can you repeat the question again, sorry?
Have you considered inserting these visual inspections into the training loop?
I think this is a really interesting idea that we would like to eventually also look into. Certainly, we have thought about how to extend this, for example, on reinforcement learning, and this is something that we're also thinking that could be beneficial for the machine learning algorithm to understand its own biases and own limitations.
Nice, thank you. Let's check again. So a question from Octavio or Matias. How do you measure the correlation of your action scores and the bias difficulty of the data?
Thank you. That's a really nice question. The situation right now is that there are not so many data sets that contain the labels of difficulty or easy samples. However, we found, for example, that the BOC 2007 dataset does contain difficulty measures, and we are looking into basically trying to answer that question with those labels. So to see if there actually this correlation exists and how much that would be. As you have seen, we have now presented some of the results on their, I guess, on more of the visual level. But yeah, this is certainly something that we would like to then improve later on.
Great.
Yeah, what can I say is that we have not computed any correlations yet because we need labels and it's a difficult problem. But definitely we want to do this into the future. Thanks.
Interesting. Okay, thank you. So I guess I have no more questions. Again, I would like to thank you all, the presenters, and yeah, let's wait for the next session. Thank you.